All right, so now we're talking about zeros of polynomials. Zero of a polynomial is a number that if you plug that number into the polynomial, you end up with a total of 0, right? So, for example, right here we can see x plus 2 as a factor. If I plug in -2 plus 2, I get 0, right? And then if this thing is 0, well, what is 0 times whatever this is, times whatever this is, times whatever this is? Well, 0 times anything is 0, right? So our goal here is to make each one of these factors equal 0. So this first one is x equals -2. Let's skip the second one. We'll come back to that. This one is x equals 1. This is x equals 3. If I plug any of those in, I get 0 in that particular spot, which makes the entire polynomial equal 0. This one here takes a little bit more effort. Let's look at it off to the side here. 2x plus 7. I want to make it equal 0. So what does x have to be? Well, if we just solve it like a nice little algebra problem, we divide that by 2, we get -7 over 2. All right, so that's -3.5 as a decimal. So now what Common would like us to do is to plot all of these zeros. So for example, we should put 1 right there. We should put 3. We should plot -2. And then we should plot -3.5. And that's it. Remember, we're trying to find a 0 wherever the polynomial will equal 0. So another word for this is an x-intercept. It's the exact same thing, right? If the polynomial is 0, the height of it on the y-axis is 0. That's the same thing as saying an x-intercept. All right, now the next assignment is what happens if everything's not factored out nice and neatly for us, like this one. Well, we're going to have to do the factoring just like we did earlier on in the year. All right, so right here, x minus 3 is already factored. We can go ahead and put 3 right on there. What we don't know is what makes this equal 0. In order to do that, we're going to have to do a little bit of factoring work. Not every one of these will have to use this certain technique, but every one of these will have to be factored in some form or fashion. So if I'm factoring this, I would have to say, all right, is there a common factor? No. Can I just say what two numbers multiplied equal 5 and add up to 7? Well, they don't exist, right? And that's because of this 2. The 2 out in front tells me I should use grouping, right? So 2 times 5, that's 10. And I'm going to come up with two numbers that multiply to equal 10 and also add up to 7. All right, if you need some help on this, check out that video on grouping on this same YouTube channel. All right, so 2 and 5 work. 2 and 5 work. Kind of a coincidence there, right? But they do. They add up to 7. So I'm going to rewrite this all out. This is how we work out grouping questions. 2x, 5x, plus 5. All right, the next step is to actually group them up. What do the first two have in common? They have a 2x in common. That would mean that x plus 1 is left over. Whenever we remove an entire term, there's a 1 left over in that factor. All right, what do these two have in common in the second group? They have a 5 in common. That also leaves an x plus 1. Remember, in grouping, our goal is to have the same thing left over. So that leaves us with x plus 1 as one of the factors and 2x plus 5 as another factor. Now remember, our goal is to plot the zeros. We already put this one on there, right? X equals 3 is already on there. This would mean x equals negative 1, right? Remember, we're figuring out what makes the factor equal 0. And then this one would be x equals negative 2.5. And I'll let you solve that on your own. But there it is. Let's do another one. All right, on ones like these, we can see there is a common factor. If I look, they have two things in common. They have a 2. They're all divisible by 2, and they each have an x. That leaves x squared plus 2x minus 3. I'm going fast. We've done this before, but if you need to pause and write that down and work through this, then that's fine. That's what that pause button is for. All right, now, really quick. Whenever you see something like this, 2x or an x squared or an x cubed out in front, what we have to do is treat that like it's its own factor. So how would I ever make the factor 2x equals 0? Well, it's really easy. I would divide by 2, and I'd end up with x equals 0. If there's ever a term out in front, like x to the third and then a group of parentheses, or x squared and then a group of parentheses, whatever is in there, both of these situations imply that one of the zeros, or x-intercepts, is 0. So if this term is ever just some kind of x, a 2x, or a 12x, or 112x, or 5,112x, still tells us the only way to make that equal 0 is if x equals 0. All right. Now, let's continue on. We need to factor everything else. What are two numbers that multiply to equal negative 3? So they have a product of negative 3. They also add up to positive 2. All right. Those would be my factors. These would be my zeros. And then that's it. I have 3 zeros on this one.